bond? Yeah, one will lose and one will gain electrons. Yeah. And what's the purpose of gaining or losing electrons and sharing electrons? What are they trying to come up with?
That one noble.
Okay, good. They don't become the noble gases, but they get to have they complete the octet rule, which says that they have the same number of valence electrons as the noble gases. Yeah. Good, good. All right, so covalent compounds, let's go ahead and get started here. And yes, I pushed record.
Beat me to it.
Well, I almost forgot, so. Covalent compounds. Often called molecular compounds. Covalent, molecular, same idea, okay? All right, so we talked about a few properties of ionic compounds, or how to tell if it's an ionic compound. Hello. So, covalent compounds are composed of nonmetals only. So if it has a metal in it, it is not a covalent compound. Are we good? And we just talked about, but they are also caused by sharing electrons. Did I spell that wrong? No. To form an octet. And covalent compounds or covalent bonds are much weaker than ionic bonds. This is what gives covalent compounds a much lower boiling point or melting point than ionic compounds. So for example, take salt, the stuff that we eat every day. Sodium chloride, that has a melting point of like 800 degrees. I can't remember if it's Celsius or Fahrenheit, but it's hot, right? And you take a covalent compound like water. What's the melting point of water? 0 degrees Celsius or 32 degrees Fahrenheit, right? So much, much weaker. And that's how we can tell it's weaker, because it has a much lower melting point or boiling point. We'll talk more about that later. Okay? All right, so we're all good with naming ionic compounds and writing chemical formulas for ionic compounds? Because today we're going to do that with covalent compounds. And a lot of students in general, and it's just easy to make a mistake, is to get them mixed up. Okay? So the very first thing you got to know is, what kind of compound is this? So let's do an example. I got too fast? Okay. You can get it. I'll have this video on Canvas. All right. So let's say we have K2O. First thing we need to know, is this an ionic compound or covalent compound? Because if it's covalent, we don't want to name it like we name ionic compounds. Or if it's ionic, we don't want to name it covalent, like a covalent compound.
Electrovalent compound.
What is it?
Electrovalent, like the ionic are the same.
Sorry. One more.
Electrovalent compound and the ionic are the same.
Electrovalent.
Electrovalent.
I've never heard of that. So, I'm not saying it's not a thing, but
No, they are like ionic and electrovalent are the same thing.
it is electricity, but it is electric. But yeah,
These are the same thing. Ionic and electrovalent.
electrovalent. Is that what you said? I don't know. I'll have to look that up. Okay. So what is this? Ionic or covalent? How do you know it's ionic, Davis? Yeah. Here's a metal and a non-metal. Has a metal in it, so that tells us right away it's ionic. So this is ionic. We're not going to name it like a covalent compound. I haven't showed you how to name it that way yet. So who can tell me the name of this compound?
Potassium oxide.
What is it?
Potassium oxide.
Potassium oxide. Good. We don't have to worry about that too? No, we do not. For monatomic ionic compound, what do I mean when I say monatomic? With one, right? No, I'm not saying monatomic. I should say I'm missing the name. It's not monatomic. I can't remember the name. Goodness. So if you have a compound with two elements only, binary. These are called binary. Thank you. Okay. Binary ionic compounds, we just name the first element, or the cation, as the element name, right? The second element, or the anion, we change the ending to IDE. That's it. We don't have to worry about the numbers. Because anytime we deal with potassium oxide, it will always be K2O. Because potassium is K plus on the periodic table. It's in group 1. So it's going to lose 1 electron to reach the octet. And oxygen is going to gain 2 electrons. And then you cross those, and you have to have 2 potassiums for every 1 oxygen to make it neutral. Are we good? That a good review? All right. So let's see. What about ionic or covalent? I'm hearing covalent. What do you think? Look at your periodic table. Look at all your paper. I'm hearing covalent. Are we good with covalent? Try again.
Is that
NH4OH. Ammonium hydroxide. What is this?
No metal.
There is no metal in it. That's right. If there is a metal, it is guaranteed to be ionic compound. If there is no metal, we have to check something else. What do we got to check? This chart here. I printed it out last time, and some of you left. If you want one of these, come get one. So these are the polyatomic ions. If a compound is made of ions, period, it is an ionic compound. Whether it has a metal or non-metal doesn't matter. If it's made of ions, it is an ionic compound. So this right here, This is NH4 plus, which is ammonium ion. An OH minus, that's the hydroxide ion. And it's a 1-to-1 ratio because they both have a plus 1 charge, one's a 1 minus charge. So it becomes NH4OH. Don't let that mess you up on the test, on the quizzes, on the midterm, on the final.
What do you mean it's
So if the compound, let's write this down. If the compound, whatever compound we're dealing with, if the compound is composed or made up of ions. You guys remember what ions are? Charged atoms, yeah, good. Charged atom. If it's made of charged atoms, made of ions, it is an ionic compound. Good? And the only compounds without metals that are ionic compounds they come from these polyatomic ions. That's it. So do you have to memorize these? What do you think? You have to become familiar with them. Did you get these? You've got to become familiar with them. Otherwise, you'll make the same mistake we did today and say, oh, that's covalent because there's no metals in it. You with me? All right. So this is the name of this guy is ammonium. And the name of this guy is hydroxide. So that's its name, ammonium hydroxide. Questions? Okay, I wrote up top here, we're talking about covalent compounds, and I haven't showed you how to name them yet. Do we fully understand how to name ionic compounds? Because if we do, it's going to be easier to name covalent compounds. Because part of it's the same. There's just one little extra part.
So is it just the first name of the
Of the element.
element, and then the next one is shortened with the I?
You just change the ending of the second element to IDE. But that's for only binary ionic compounds, right? Well, yeah, binary. If it has polyatomic ions in it, then we just use the polyatomic ion name. That's the only difference, right? We ready to learn how to name covalent compounds? Or do we need another example? All right. Let's name this one. We all know what that is. We call it water. But what's its chemical name? Let's learn how to do this. So naming covalent compounds. So again, we still have to, or our first step is what type of compound is it? If it's ionic, don't name it this way. If it's covalent, let's go ahead and follow these steps. So step one, I'll just put this down. What type of compound is it? And I guess we should put this on the step one of ionic compounds too, right? Okay, step two is we name the first element using the element name. Same thing. And step three, we name the second element by changing the ending to IDE. That's the same, right? And we can call this the fourth step, or just mix it in step 2 and step 3. Use the correct prefixes for both the first and second element. I haven't told you the prefixes yet. We'll get there. We got to use prefixes. And you talked about a certain prefix last time. You used di. Have you ever heard of carbon dioxide? That's a covalent compound. That's how we name it. So there is one exception here, and you need to know this exception. We don't use a prefix for the first element if there are only one of them. If there is only one atom. We okay? Questions? I mean, I'm sure we have a lot of questions. I haven't showed you the prefixes yet, right? So let me give you the prefixes. So we got the prefix for 1 is mono. Monotone. Have you ever heard of monotone singer? Sounds awful, right? Well, sometimes their part is monotone, but okay, whatever. 2 means die, kind of like dicycle, right? Oh, no, that's, I don't know why we use die, but we do. Okay. Okay, 3 is, we should all know this, it's from mathematics. Try. 4 is not from mathematics, it's from video games. You guys ever play Tetris? Why do we call Tetris Tetris? There's each piece, here's the best piece, right? Wish all of them were this, right? And then you got the worst piece. This one's okay. This one's sometimes funky. And we got that one. They all have 4 pieces, right? Tetra means 4. If you've never played Tetris, I'm sorry I wasted your time. Or never heard of it, okay. 5 is from mathematics, from geometry. Penta, like a pentagon, right? And then 6, 6-sided object is called hexagon or hexa. 7 is not common, hepta. 8, we should know, is octa. 9, also not real common, nona, and 10 deca. Good? Can we see this okay? Okay. Now let's name water. Anybody want to give it a shot?
Dihydrogen monoxide.
Dihydrogen monoxide. That's it. So we still use the first element, we still use the element name. We just use the prefix di because there's two of them. Remember, the number goes after the element, okay? And then how many oxygens are there? One, so we use mono. But we don't say monooxide because it looks like monoxide. Too many syllables, we try to simplify it, and we just say monoxide. But remember, on the test, it's multiple choice, and I'm not going to trick you like that, okay? You'll be fine. All right, so what about what's that called?
Calcium oxide.
What?
Calcium oxide.
Calcium oxide? How do you know? Because it's an ionic compound. Some of you are probably thinking, oh, that should be calcium monoxide, right? There's a metal in there, so watch that every time. That's not an ionic compound, so that's calcium. What did I say? It's not a what? It's an ionic compound. It's not a covalent compound. Calcium oxide. Done. Okay. What about C2H6? Dicarbon hexahydride. Still change the ending to IDE. Dicarbon. Use the element name for the first one. Hexa 6. Change the ending to IDE. We're not going to call it hydrogide. Too many syllables, right? Hydride. That's it. That'll tell us it's hydrogen. There's no other element that's named similar to that. Okay? Are we good? What about CO is a common one we deal with in everyday life. Notice we don't use monocarbon. We don't use mono for the first one only, right? If there's only one on the first one, we don't use a prefix. So carbon monoxide. And this is, they say it's poisonous gas. It's not really poisonous, it's just heavier than air. And if we ingest it, it's going to suffocate us, right? Questions? All right. On the worksheet that you picked up, there are more examples on the very back. What about writing chemical formulas? how do we do this? What if we have carbon tetrahydride? Can you tell me what the chemical formula is?
CH4,
Tetra means
CH4,
4, so CH4. It's just,
called methane.
what's that?
It's called methane.
Methane, yep. This is natural gas, stuff we have to heat our homes, or if we have a, yeah. Good. Is that straightforward, guys? How to write the chemical formula? Do you have any questions? Okay, what about, let's, what about dinitrogen pentoxide? N2O5. Di means 2, penta means 5. So you just have to make sure you get these down, right? Or make sure they're on your reference sheet. But it's only 10 items. It's like a phone number. I know nowadays we don't have to memorize phone numbers, but okay. Good. Should we do a couple more on this worksheet? What do you think? Okay. All right, let's do SF6. Everybody name it on your paper. Don't tell me, because I want everybody to try it. Because if you tell me, then everybody doesn't have to do it, because somebody already gave us the answer, right? So this is on your worksheet, on the back side. And do OBR2 as well. And P2O5. And sulfur dioxide. So name the first three and write the chemical formula for the last one. And I don't know if you've been looking at modules. It says we're going to learn this later, but I feel like it's important to learn at the same time so you don't get them mixed up. Anyway. Can I call on you to name them? Or is that too embarrassing? All right, let's go with Parker. What's SF6 called?
I did sulfur hexafluoride.
That's it. sulfur hexafluoride. Andrea, is that? No? Yeah. Is that your name? Okay, making sure. P2O5. Can you do that one? Not yet? Okay. Do you know the prefix for 2?
Yeah, it's diamond.
Uh-huh. And what's the prefix for 5? Penta, good. Okay, so give it a shot. And P is, now we got to look at the periodic table, right?
Diphosphorus.
Good.
And oxygen.
Except for we changed the ending to IDE. Uh-huh. Are we good? So, and that, guys, we're all learning here. So it's 100% okay. I know that's probably not comfortable, and I apologize. But we've got to do these. And until you do them, that's the way it's going to be. It's going to say, oh, I don't know how to do this. So you got to own it. Is that okay? Thank you. I appreciate that. What about Charlie? What about this one? OBR2.
Oxygen diboride? Boride?
Close. BR.
Oh, BR.
Uh-huh. It's under number 17. It's on the right side of the periodic table.
Oxygen dibromide.
Oxygen dibromide, perfect. Okay. And who can tell me what sulfur dioxide? Let's go to. Do you want to do it, Eric? Sulfur dioxide. What is it?
SO2.
SO2. That's it. Why don't you practice those for a minute? I'm gonna take a little break. If you want to take a break, go ahead. Okay, do we have any questions on covalent compounds so far? another thing we got to do is draw the structures. We don't draw structures for ionic compounds, but for covalent compounds we do. Because ionic compounds just hook together, right? All right. So let's talk about electronegativity. I'm going to pull up my periodic table real quick. Does anybody know what electronegativity means? Yeah, go ahead.
How strong, like it is, like the atom is itself, like, yeah, like, how strong the connection, or how strong it holds its its electrons.
That's it. Okay? It's the ability, it's the atom's ability to not just hold on to, but to accept electrons during a chemical reaction. And this will only happen during a chemical reaction. Ions won't form until there's a chemical reaction, right? Okay. All right, so going from left to right, the electronegativity increases. Now, this one's the most simple part of this to understand. So let's make sure we get this. Why is fluorine more electronegative than lithium? Why does fluorine want to accept those electrons more than lithium does?
Is it less stable?
They're both not very stable, right? Or when I say stable, when we say stability, we're not talking about nuclear instability, right? So, yeah, nonmetals tend to gain electrons. We talked about this making ions, right? And metals tend to lose electrons, right? Lithium wants to be similar to helium, so it loses an electron. And fluorine wants to gain an electron to be similar to neon, its closest noble gas, right? Remember talking about this? Okay. So we can see that fluorine is more electronegative than lithium. But what about from top to bottom? Does everybody get that idea? From left to right, electronegativity increases. Okay? What about top to bottom? Any ideas? I heard increases. Is that what I heard? Decreases? Why decreases? Okay, perfect. Not a problem. So it is decreases. So as we go down on the periodic table, from fluorine to iodine, let's say, iodine has more protons, right? And what's the thing that's attracting the electrons? The protons. Positives attract negatives, right? So it seems like iodine would attract more electrons more than fluorine, right? But there's one other thing. I mean, these things have to obey the laws of physics. And there's a law in physics that says, well, we know this law. We might not know exactly what the law states, But let's say I have a magnet. Same thing with magnetism and electricity. If you have a magnet and you hold it up here, have my keys here, hold my magnet way up here, is it going to attract it? There is an attraction, but it's not going to lift it, right? I have to put it a lot closer before it's going to pick it up, right? So even though this big heavy magnet, like this, maybe one of those neodymium magnets, those strong, you guys ever play with those? Okay, that's what iodine is, big strong magnet, but it's way up here. Because as you go further down, you have more of those shells, right? More energy levels. So the highest electrons, or the valence electrons, are way out here. Does that kind of make sense? But fluorine, well, the closest electron is way down here. So even one of those fridge magnets will hook it up, right? Even if it's not a strong magnet, it'll still connect it. Magnetism, electricity, they all follow the same law, same principle. And it's the same thing when you look with light. How do we see? Because light reflects into our eyes and we see objects, right? So when you're looking out on the horizon, we see the mountain out there, right? Mountain, right? And we go like this, say, oh, that mountain is this big, just a few inches high. It's not really a few inches high, but if we do that, we can put the mountain in between our two fingers, right? If we can get a lot closer, then it's going to be like this. Oh, now it's that big. But if we get a lot closer, we can't do it, right? So the strength is a lot more when you're closer to it. Are we good? So I didn't give you any equations, so I didn't give you any physics, but that's physics, right? These things have to follow the laws of physics. Questions on that? Yeah.
What does heat make like a magnet weaker? Like why is it like?
That sounds to me like a physics
That's a
question.
Curious.
Why does heat do what?
Like create, like make a magnet like weaker or like why does like electricity make it strong?
Here's my best effort. So the electrons are moving, right? Everything's moving, not just the electrons, the atom, everything in the atom, right? Everything's moving. If you heat it up, it moves faster. Okay, now let's say we want something to go from here to here. And this is more for electricity. It's easier to explain electricity, but magnetism, I'm sure it's similar. Okay? So you have an electron. If let's say you guys are all the protons or the different particles inside the material, and you have the electrons trying to get from this side to over here. If everybody was moving really fast, would it be hard or easy for that electron to get through? Harder. But if it's cold, everybody's moving slowly, right? Then it can easily get through. Does that make sense? Okay, there's your physics lesson 2. All right, any other physics questions? No, I'm just kidding. All right, you won't need to know that, guys, but okay, there you go. Does everybody understand that part of it? Well, good. Now you're going to be mad at me because you don't really have to know that if you don't want to, but it's good to know stuff, right? If you understand why something is the way that it is, you're going to remember it better. Or if you forget it, you can come up with it better. That's why I bring it up. So let me show you what you get. If you have this on your reference sheet, and you guys picked this sheet up, right? Okay, it's over there if you want it. I would get all the material there, and you can cut this out, shrink it down, take a picture of it, shrink it down, and stick it on your reference sheet, right? And you can use it. But this is what it is. It's just kind of like a periodic table with the electronegativity values. Has the actual values on there. So the electronegativity value for hydrogen is what? 2.1 right there. Whoops. Right here. Electronegativity value for all the noble gases are what? Well, they don't have one. Why not? They do not want to take any electrons, right? They're noble gases. They're good where they're at. That's why there's no electronegativity value. The ones on the left side are small numbers.
Why the krypton and neon have first?
What's that?
Why the krypton and xenon have the,
Why don't they have electronegativity values?
they have,
They don't. That's the 2, 10, 18, 36, 54. What's that number?
krypton.
That is the atomic number. Tells us how many protons.
Electronegativity value.
It does have one?
Yeah.
Mm,
On ours, it says 3.0
Oh.
krypton.
okay. I've updated my chart since then. It shouldn't have any. You can cancel those out. No, they shouldn't have any. All right. Does that make sense? So what's the most electronegative element on the periodic table?
Fluorine.
Fluorine. It's farthest to the right, increases to the right, and it's farthest up. So decrease is going down. That means the increase is going up, right? And again, you don't have to memorize that, but hopefully that little physics information will help you to understand why it is the way that it is. All right. Okay, so that page will be good to have on the midterm, on the final. Good to have that, because you don't want to memorize all those numbers, right? Yeah. Don't memorize them. Okay, we learned that so that we can do the next thing. Are we good? Ready to move on? Okay, next we're going to talk about Lewis structures. And why are they called Lewis structures? Because a guy named Lewis come up with them. Why do we do this? Because somebody said this is the way we're going to do it, and it stuck. It made sense to everybody, and we went with them. Okay? But it really is, in theory, that's the way that it is. Okay? Again, we can't see these things, but physics tells us that's the way that it is. Okay? All right. So step one, to draw the Lewis structure of a covalent compound. We don't draw these for ionic compounds, just for covalent. Step one is we count the valence electrons in that compound. Do we remember how to determine the valence electrons, number of valence electrons? The group number on the top, right? And we can only do this for main group elements, but we're only dealing with main group elements because we're dealing with nonmetals here, right? Only nonmetals. So we don't have to worry about the transition metals because we're dealing with covalent compounds, right? Okay. Step two is determine the central atom. What atom is in the center of our compound? How do we do that? It is the least electronegative. Usually. In fact, I don't, well, there is one exception. I'll tell you that in a sec. Least electronegative, One exception, hydrogen is never the central atom. Why not?
Because it's supposed to only have one proton.
It does have one proton, but it also only has one electron. And how many electrons does it want to have?
One.
Either 0, we'll talk about later, or 2. What's the nearest noble gas to hydrogen? Helium, which is 2, right? It wants to have 2. If we had hydrogen bonded to, let's say, 2 carbons, how many electrons, and if they're sharing these electrons, how many electrons are near to hydrogen? 4. That can't happen. Well, it's too much for hydrogen. He's just a little guy, right? So that's not going to happen. I know I just drew a structure and you're not sure what I'm drawing here, but we'll get there, okay? So hydrogen will never be the central atom. It can only be bonded to one other atom, not any more than one, okay? Okay, let's do step 3. Bond all other atoms to the central atom. And we'll put in a note here. A bond consists of 2 electrons, shared one from one atom, one from the other atom. Because covalent compounds, they share electrons. Are we good? Step 4, place remaining electrons When I say remaining electrons, what am I talking about? Well, our first step was to count valence electrons. That's all we get to use. We can't use any more, any less. Have to use that number. So if we count that number wrong, our answer is going to be wrong. Okay? Make sure you know how to count valence electrons. We'll do some examples. So place the remaining electrons after all the other atoms are bonded to the central atom around all atoms to make them form the octet or an octet. One more step. Step 5. If the octet, so you use all the electrons and the octet doesn't happen. If the octet doesn't exist for any atom, then just keep sharing. Because we're just sharing these electrons to make everybody happy. And when we keep sharing, we form double and triple bonds. And we'll do all these examples, ladies and gents. Don't worry, we'll get there. But write this down and follow these steps until you get good at it. And just to let you know, this Lewis structure is the first step of many to get to where we're going. Okay, so you got to know this to do something else. You got to know that something to do something else, and so on. This is just the first step. Make sure you get this down, okay? Ready to move on? You have these down? Okay. Let's do some examples. Start real simple. Let's start with carbon. Is that a covalent compound?
No.
No, that's just a single element, right? Let's just start simple. Okay? First step is what? Count valence electrons. How many valence electrons does carbon have? It has 4 electrons. Okay, so there we go. What's the central atom? Oh, there's only one atom. Just carbon, right? We have no atoms to bond to it. How many electrons have we used? We haven't used any yet. We just wrote carbon. So now let's draw, and I kind of drew one of these for you, I think last time. But let's draw the valence electrons. 1, 2, 3, 4. That's it. And how many do they want? Well, in a chemical reaction, they want 8, right? They want that octet. But this is not a chemical reaction, so we're okay with just writing 4. Are we good? So that's the Lewis structure for a single element. Let's draw the Lewis structure for phosphorus. Go ahead. Or do you need me to do one more? Use the periodic table. Count the valence electrons. 5 dots. One, 2, 3, 4, 5. Why do I draw it that way? Electrons don't want to be by each other unless they have to, right? And I know that's not the way that it looks. So you might ask, well, why do we do it that way? Because of Lewis, okay? That's the way he did it, so that's the way we're going to do it, okay? And it'll make more sense as we move on, hopefully. Are we good with single elements? All right, let's do water. I like water, so I deal with it a lot, okay? Okay, first step. Count valence electrons. How many valence electrons does hydrogen have? It just has 1. But how many hydrogens do we have up here? 2. So we have to multiply that by 2. Plus, how many valence electrons does oxygen have? 6. Does everybody understand how to count valence electrons using the periodic table? If you don't, say something right now, or you're going to, yeah. Need a reminder?
Yeah.
Okay, perfect. So on the periodic table, group 1 elements have 1 valence electron. Group 2 have 2 valence electrons. Because if you write the electron configuration, this group always ends with S1. This one's 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1.
Oh, okay, so it's this
Yeah.
table that
But you can only know how many valence electrons there are looking at the periodic table for the main group elements. That's the S group and the P group, right?
Oh, okay.
So group 13 has how many valence electrons? 3. Sometimes I call that group 3-teen. Group 14 has 4, group 15 has 5, group 16 has 6, group 17 has 7, and group 18 has 8, except for, which one?
Helium.
Helium only has 2 electrons total, right? So helium's octet is 2. So is hydrogen's octet. because the nearest noble gas to hydrogen is helium. You following?
Yeah.
Giving you too much information? I'm doing okay. Make sure you study this stuff. I'm giving you a lot of information here, right? Study it within 24 hours. Otherwise, you're going to, luckily I have videos, but then you just have to spend more time watching videos, right? So it's better if you, 24 hours, you study this stuff again, okay? All right, let's do water. So we have a total of how many valence electrons for water? 8. Are we good? Can we do this? All right, what's our next step? Look at our steps.
Write the elements.
First, we do the central atom. Which one is the central atom out of hydrogen and oxygen? Oxygen. It's never going to be hydrogen, right? And let's bond the 2 hydrogens to it. And when I do a bond, in fact, let me do this using this method first. I don't like using that method just because it's longer. But let me show you just to make you understand kind of what we're doing here. Uh-oh, wrong one. Okay. So we have oxygen. If we draw the Lewis structure for oxygen, it looks something like that, right? Has 6 valence electrons. If we draw it for hydrogen, it has 1 valence electron. But what do they do? What happens to the electrons in a covalent compound? They share. You with me? Do you see how that works? But if you follow my steps, you don't have to draw all these dots. Are we okay? But if you like drawing those dots because this makes you feel all fuzzy inside, do it. Okay? All right. But I didn't I kind of skipped a step here. How many electrons have we used? So I wrote the central atom, bonded the rest of the atoms onto it. And each bond represents 2 electrons, so we used 4, right? So we subtract 4, and we have 4 electrons left. Where do we put the remaining electrons? Around all the atoms so that they all make an octet. Well, do we need to put any around hydrogen? Hydrogen has 2 right now. What is hydrogen's octet? 2, just like helium. The closest noble gas to hydrogen is helium, so it only wants 2, because that first energy level can only have 2. You with me? It's still a full valence shell, and that's what the octet means. Has a full valence shell. Outside energy level is full. So these 2 electrons already have full shells. So we're going to put them right there and right there. You will always have an even amount. So if you count these and you don't have an even amount, you made a mistake somewhere. Are we good? So that's the Lewis structure for water. Let's do another one. CH4. First step, count valence electrons, right? How many valence electrons does carbon have? 4. How about hydrogen? Has 1. It wants to have 2, but it only has 1, right? Because it's in group 1. And there are 4 of them, though. So that's a total of 8 valence electrons. Are you all with me? Or did I draw that too small? That better? Okay. All right. What's the central atom? Carbon is a central atom. And then we bond. There's 4 hydrogens, so we have to put all 4 of them around it. How many electrons have we used so far? Each bond represents how many electrons? 2, so we used 8. That means we're done. But we have to check something. Do they all have octets? Carbon has how many? 8. Each hydrogen has how many? 2, but that's hydrogen's octet, right? So yeah, that's it. Are we good? Do you want to do more simple examples or move on to the next one? Move on to the next one? Okay, let's do it. Okay, for polyatomic ions. Why are we dealing with polyatomic ions? What kind of compound is a polyatomic ion? For example, we have NH4 plus. There's a polyatomic ion. Is that a covalent compound or ionic compound? That's what most people say when they first learn this. This is a covalent compound because it's not made of ions. It is an ion. It's not made of ions. So a polyatomic ion by itself is a covalent compound with a charge. Are we good? Or did I just mess you up? Yeah? Okay. So this is a covalent compound, so we're going to draw a Lewis structure for these. First step, count the valence electrons. How many does nitrogen have? 5. How many does hydrogen have? 1. How many are there? 4. That's a total of what? Uh-oh. Something's wrong. What does this tell us? If it's a positive charge, why does it have a positive charge? It lost how many? 1, because it's plus 1. It lost 1 electron, so we have to account for that. It lost 1 electron, so we have a total of 8 electrons. Questions? Okay. What's our essential atom? Nitrogen. And bond the 4 hydrogens to it. How many have we used? 8. We're done. Do they all have octets? Yeah, they do. There's one other thing we have to do for polyatomic ions. It's a charged molecule, so we have to represent that charge by putting brackets and the charge in the upper right-hand corner of that bracket. We only have to do that for polyatomic ions. Good? So they are, some of them have more than 2, but they're just nonmetals. They're just charged. Yep, they're on this chart. Does anybody need this chart? You need this chart if you don't want to have to memorize them. I would come and get this chart if you don't have it. And find a way to put those on your reference sheet that you get for the midterm, which is going to be when? Like the end of June? Close to the end of June? Okay. So make sure we are getting ready for that, getting our reference sheet ready for that midterm. Because you, on the unit test, you get all your notes, right? On the midterm, you just get 1 sheet of notes, double-sided. That's it. If you're not getting it ready right now, you're hurting yourself. Get that ready. Okay? And everybody's going to look different. Because some of us know this topic okay, but this topic they need a little help with, right? But at least have, if you don't want to memorize these polyatomic ions and the prefixes and whatever you need, right? All right. Should do another polyatomic ion? Okay, let's do nitrate, NO3 minus. You waiting for me, or do you want to do it by yourself? Because it's easy when I do it, right? And then you get home and you try the homework, it's like, oh, I thought I understood it, but now I don't, right? Or is that just me? How many valence electrons did you get? Let's make sure we got that right, because if we don't have that right, we're stuck. How many?
11.
No, it's not 11. It's not 23. Both of those are odd numbers.
22,
Has to be even.
22,
Let's count again. So we got 5 for nitrogen, right? 6 for oxygen, but there's 3 of them. That's a total of 18. Plus 5 is 23, plus the 1 for the negative charge, right? That negative charge means it gained an electron. So we have a total of 24 electrons. You with me? So if it's positive, we lose an electron. Make sure, don't just memorize that. Make sure you understand why it does that. And if it's negative, it gains an electron. Good? All right. Can you do it from here, or just keep going? Okay. All right, what's the central atom? Yeah, it's, so I mentioned that it's the least electronegative, but where's nitrogen relative to oxygen on the periodic table? Furthest to the left, right? Yeah, furthest to the left is least electronegative, right? So that is, I think, always the case. Can't say for sure. But another way to tell is it only has one atom, and the other oxygen has 3, right? So it's all by itself. That's the central atom. Okay, we bond the 3 oxygens around it. Does it matter where I put them? Could I put it on the bottom instead of on top? Yeah, it doesn't matter. Okay. How many electrons have we used? 2, 4, 6. Each bond is 2 electrons. So subtract 6, we have 18 left. Where do we put them? Not until we draw the rest of the dots. Okay? So yeah, we might add another bond here, but we don't add bonds until all electrons are completely used up. Okay? So if you look at your steps, it says use all your electrons. Once you use them all and you still don't have octets, then you make double and triple bonds. Okay? So we're going to put them around the most electronegative elements first. Does that make sense? Why? Because they want the electrons, right? So we're going to put them around oxygens until oxygen has an octet. I put 6 around that oxygen, but it already had 2. So now it has 8. Are we good? So I did 6. That means I have 12 left. 2, 4, 6. 6 left. 2, 4, 6. I don't have any left. They're all used. Do we have octets for all atoms?
Yes.
Except for nitrogen only has 6. So what do we do? We share more. We keep sharing. We take 2 from one of these oxygens have plenty of electrons around them, right? They're going to just share. Does it matter which oxygen shares? No, it doesn't. When you get into higher chemistry, anybody going to take organic chemistry? If you take organic chemistry, then you're going to deal with resonance structures. But we're not going to do that in this class, okay? So it doesn't matter which one you do, which one you share. I like to keep things symmetric. That's why I did the center one. But it doesn't matter. It really doesn't. Because these electrons are going to try to make everything balanced, so they're going to move wherever they have to be. Anyway, you don't need to worry about that. Okay?
So on the exam, we just going to do this, or are we also gonna do draw? Are we gonna do both? Are you going to ask us both?
Well,
or you're just-
fortunately, it's multiple choice. And so you just have to tell me which one's the right one. Right?
But you still need to know how to get.
Yeah, I would draw it for sure. And then check to see and double check. Measure twice, cut once, right? Are we missing anything?
The bracket.
The brackets and the charge, good. Don't forget that. And if it's multiple choice, and you look at all of the options, then you'll, oh yeah, I forgot the brackets, right? But if you get in the habit of just going for the first one that looks right, oh yeah, it's A. You might miss it. So always look at each option, right? All right. Are we good with polyatomic ions? Okay, let's move on to, we just did a double bond there, but let's move on to more double and triple bonds. So let's do oxygen, and let's do carbon dioxide. I'm going to let you guys do oxygen by yourself, because that's a small one. And then if you need help with carbon dioxide, why do I call this oxygen and not dioxide? Because it's one of those diatomic molecules. You remember those? We learned it last time, so if you wasn't here last time, you missed it. Diatomic molecules, there's 7 of them. Starts at number 7. We draw 7, and the 7th one is hydrogen. Watch my video if you missed it. How many valence electrons does oxygen have? O2. 12. Did everybody count 12? 6 apiece, and there's 2 of them, right? Anybody want to tell me what oxygen structure looks like? Go ahead. You want to draw it?
Might be wrong.
what I got. All right, what do you guys think?
Two more electrons.
Well, let's count them. Let's count them. We have 2, 4, 6, 8, 10, 12. We use 12 electrons. That's good. You have to use 12, so count when you're done. Make sure you count it correctly. Do they all have octets? 8 there. 8 there. Good. That's it. Questions? Yeah?
So you know how you said we have to fill the whole thing before we can double up?
That's right. Should we do this one?
So do we have to put like a dot on the bottom?
Let me show. Let's do this one. Good. So we have oxygen bonded with oxygen, right? And there you don't have to worry about the central atom because they're both the same. But we used 2 there, so we have 10 left. 2, 4, 6, 8, 10. Right? That one has an octet, but this one does not. So what does that tell us we have to do? We have to keep sharing. Well, they both have extra electrons. Who has more extra? The one on the left. We try to be symmetric whenever we can. So we just put those 2 electrons that were here and we moved them over there. But since we did that, this oxygen still has an octet. He's not going to share his electrons if it's not going to make him have an octet, or it, right? It's not a boy. Sorry. And right there, they all both have octets. Good? Does that help? Thanks. Are we all good?
Can we do CO2, please?
Yeah, do it.
Oh.
Oh, do you want us to do it together? Or do you want to try it?
I mean, I just already did it.
Oh, so do you want to give us your answer? Is that too scary?
I can give you the answer. I can't promise it'll be correct.
That's okay. How many times are we correct in life, guys? Well, this is how we learn. This is how we live, right? We make mistakes. It's fine. Okay, what do you got?
Okay.
You want to draw it?
Okay, so the carbon has 4 valence
You
electrons.
can just draw it right. You could just draw it right here.
Oh, okay. Carbon has 4 valence
Just draw it. If you already you already have it done.
I mean, this is what I have?
Right there.
Yeah? So just draw that?
Sure. If you feel like that's right.
I don't.
Okay. Count it. Did you count right?
It is counted correctly. Both the oxygens has.
Do they all have octets? Make sure you answer. Go through all those steps, and make sure they all have an octet.
Never mind.
Are we good? I mean, should we go through this one? Okay. Sorry, I thought you wanted to just draw it for me. All right, so how many valence electrons do we have for carbon dioxide? How many? 16. Did everybody count 16? Okay. Which one's our central atom? Carbon is. And we have 2 oxygens, so put them on there. Now, how many electrons have we used so far? 4. So we have 12 left. Where do they go?
4 on each.
2, 4, 6, 8, 10, 12. We put them around oxygen first because it's most electronegative, right? We don't have any more. And I think that's what you got, right?
Yeah.
Yeah, that's what you got. So what's our last step before we make doubles and triple bonds? Count to make sure they have, do we need brackets on this one? Why not?
Even have charge.
It doesn't have a charge, right? Only for polyatomic ions, okay? And so, do the oxygens have an octet? Yeah. Does the carbon? No, it doesn't. What does that tell us? We keep sharing, right? We keep sharing. So we're going to take these two and put it right there. Should I take these two and put it right there? Would that work? It would work. But what's better than that? Take two on this side. Why? Because everybody had an octet before too. The reason why is because it's more symmetrical. Think about going down the highway. If everything's all symmetrical, it's going to be balanced, right? These things are moving. That's why I talked about being a tire. They're moving. They're turning. And so you want to make them as symmetrical as you can. Sometimes you can't help, and it's not going to be symmetric. But if you can, make it symmetric. Good? So it looks like this. Now, you can draw like this if you want, right? That's okay. Are we good? All right. Anything else? Let's do one more. Go ahead and try that one. How many valence electrons does nitrogen have? How many? Nitrogen gas. When I say nitrogen, nitrogen cannot exist as N, right? This is one of those diatomic molecules. So, yeah, so it has 5, but there's 2 of them, right? So it has a total of 10 electrons. Good? What does this look like? Triple bond, right? Should we go through that? Okay, here we go. How many electrons have we used? Just 2, so we have 8 left. Put them around the nitrogens until they're used. We used all 8, or all 10 total. This nitrogen does not have an octet. So we got to keep sharing. Let's take these 2 away. Why do we take them from the one on the left? Whoops. Because he has more of them, right? This still has an octet, but the one on the right still doesn't. So we just keep sharing. Now they both have octets. We're good? almost done. We're going to get out early again tonight. You guys okay with that? Yes, please. Okay. Questions so far? There are some exceptions. Why, right? There's a few exceptions, and I'm not going to promise you that they're not on the test. I don't think they are, but I'm going to show you anyway, just in case. Why don't you know? Didn't you write the test? No, I didn't write the test. It's the chemistry department here wrote it, and so here we go. I mean, I've looked at it before. I can't remember if it's on there though. It might be on test 2, but I don't think it's on the midterm. But here we go. I know this compound is on the midterm, but I don't think it tells you to draw the Lewis structure. So here we go. So we got BF3 is one of them. So if we draw the Lewis structure here, we know that boron has 3 valence electrons, and fluorine has 7 times 3,
21.
so it has 21 plus 3 is 24 electrons. Good? Okay. So boron's the central atom. 3 fluorine took to it. 2, 4, 6. We have 18 left. You following me, or am I going too fast? Good? All right. And then we have 18 left, so 2, 4, 6, 8, 10, 12, 14, 16, 18. Put them around fluorines because they're the most electronegative. We don't have any more. Do they all have an octet? They don't, but we're done. This has less than an octet. This is an exception. Now let me show you where this exception takes place, when it takes place. How many valence electrons does boron have? 3. 1, 2, 3. It still has 3. How many valence electrons does fluorine have? 1, 2, 3, 4, 5, 6, 7. It still has 7. That's the only time the exception occurs. Not the only molecule, but the only time it occurs. Okay? So let's do another one. Have SF6. Sulfur has how many valence electrons? 6. Fluorine has how many? 7 multiply 6. 42 plus 6 is 48. Ooh, that one looks like a mess. Which one's the central atom? Sulfur. And we have we already know that has more than an octet on sulfur, right? Can't do that, but we can. How many valence electrons does sulfur have? 1, 2, 3, 4, 5, 6. Okay, how many electrons have we used so far? 2, 4, 6 times 2 is 12. 36 left. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Uh-oh. 32, 34, 36. We used them all, and fluorine still has 7. How many it started with? So that's an expanded octet. So if it looks like, I have too many electrons, or, not enough, then just check that. Good? But I'm almost certain that you won't need to know that. There, on the midterm, this is on there. Midterm or final, one of them. But it's going to be talking about something else. It won't say, what is the structure? What's the Lewis structure? Are we good? That's it. Do we have any questions? Anything stuck in your mind? All right. Have a good night.